This video illustrates some of at-risk's Six Sigma functions in an example of process capability. Consider a system composed of 5 probabilistically independent components. The system functions properly only if all 5 of the components fall within their respective lower and upper specification limits, shown in rows 4 and 5. The target value for each component is midway between its LSL and USL values. The actual values for the components are normally distributed, with the means and standard deviations shown in rows 10 and 11. Note that the means are close but not all exactly equal to the component targets. This means that some components have a slightly larger probability of being beyond one specification limit than the other. The model is partly set up. There are risk normal functions in row 15, and there are if functions in row 16 to indicate whether the components are within their specification limits. The system functions only if each of the values in row 16 is 1. So the product of these 1s and 0s in cell C24 indicates whether the system functions. And it has been designated as an at-risk output cell. Also, the risk mean function in cell C25 will eventually show the probability that the system functions. The model at this point is perfectly adequate, but more information can be obtained with at-risk's Six Sigma functions. The first step is to designate each of the cells in row 15 as an at-risk output cell, but to tack on information about its specification limits with the risk Six Sigma property function. I will do it for component 1 in such a way that its formula can be copied across for the other components. There is the risk Six Sigma function, which has been tacked on to the risk output function. And because I made all the addresses relative, I can copy across. Once the risk Six Sigma function has been tacked onto these risk output functions, at-risk Six Sigma statistical functions can be used, just like other at-risk statistical functions. I will use 3 of the most popular of them in rows 19 to 21. They are explained in the text box. As with other at-risk statistical functions, the values in these cells aren't meaningful until the simulation is run. Now I will run the simulation. First, you can see the probability that the system functions in cell C25, which is slightly greater than 99%. This value doesn't rely on any of the Six Sigma functions. Second, to see the effect of the Six Sigma functions, I will look at the histogram of component 1. You can see the specification limits and the target on the chart. And you can move the sliders to these specification limits if you like. Alternatively, You can see the values of the Six Sigma functions in rows 19 to 21. For example, CPK for each component is very close to 1, except for component 4, meaning that the mean for each of these other components is about 3 standard deviations from its closest specification limit. Similarly, the P and C values are all quite small. But when they are multiplied by 1 million to get the DPM values, there are sizable numbers of non-conforming components if the process runs long enough.